All right, so we're going to start 1.2, measuring and constructing segments. First off, before we go any further, let's take a look at the math humor question. What did the little acorn say when it grew up? Answer?
Gee, I'm a tree.
Oh, man, that's just great.
That's awesome.
So,
all right.
When we're taking a look at these notes, notice we've got 5 warm-up questions. What we're going to have you do with these warm-up questions is you're going to work on those on your own. You're going to pause the video, and then when you come back, you're actually going to have answers written by moi with things that you can check your answers. Number 5, those are lines, just to make sure you've got that down. And in number 3, that's the ray GD. All right, so go ahead, pause the video, try it out on your own. So taking a look at number 1, we're going to name the line in 2 different ways. One way in which you can name the line is by naming it line RS, or you can name it line TS, you can name it line RT, you can name it line ST. There are so many different ways which you can name the line. Just make sure that you're picking 2 points that sit on the line, and when you name it, you put that line symbol above the 2 points. Please don't write line RST, because by definition, a line is determined by 2 points, not 3. Number 2. If you name the segment in 2 different ways, you can name it segment DE, or you can name it segment ED. Just like with a line, you need to tell me, what are we talking about? We're talking about a segment, so you need to put that on top. Number 3, the end point of ray GD. Remember, when you name a ray, you're naming it with the end point first, so the end point is G. Number 4, naming that ray, there are 2 possible ways in which you can name this ray. Either you're going to name it ray RW, or you're going to name it ray RZ. Make sure that you're always starting off with the end point on that ray. Please do not write ray RWZ. You do not use 3 points, you only use 2, just like in lines and segments. And then number 5, hopefully you had some sort of drawing like what I have got down below. And make sure that you are labeling these. I want to see arrows on the ends of the lines. I want to see points for where you need to have the points. And then make sure you label all of those points. And they intersect at point S. The first main concept that we're going to talk about in this set of notes is distance. And what is distance? Well, it's the absolute value of the difference of the coordinates. Those keywords should click something off in your brain from your previous math classes. Absolute value. When you take the absolute value of a quantity, you always get a positive value. Difference means subtraction. So what we're going to do is we're going to subtract 2 values and take their absolute value. So when you talk about distance, though, a key thing with distance to remember is that length, distance, they mean the same thing. It is always positive. Huge to remember. Did you want to say something?
Sure.
Sorry.
I would just like to think about it as if you take 4 steps forward and 6 steps back, you're taking a total of 10 steps. Just because you go backwards, it doesn't mean that you're subtracting steps. Distance is always positive. Always going to be positive.
So if we take a look at the distance between the points A and B, that is considered the length of segment AB. To figure that out, all you have to do is take the coordinate at A, whatever that value is, and subtract off the coordinate at B, whatever that value is. That's the difference that we're talking about. And once you take the difference, then you take the absolute value to ensure it is positive. You can either do A minus B or you can do B minus A. It does not matter due to the fact that you're taking the absolute value. So this is really, really important for you to remember. Make sure you've got this box circled, highlighted. Do something to it in your notes so you've got that down. First example, we're going to take a look at then using the distance formula. We're going to find out the length of segment XY and the length of XZ. Good call. Nice job on that. XZ. So XY, the first one, well, we have XZ. Oh man, this is going downhill. We have XY is the first one we're taking a look at. So XY, that means I need to find out what the coordinates for X and Y are. So taking a look at X sits at 1.5. And y sits at 5. So when we find the distance, we are taking the absolute value of the coordinate at x, which is 1.5, minus the coordinate at y, which was 5. And when you do this, you're going to end up getting the absolute value of a negative 3.5. And we all know that if you take the absolute value of a negative spits out a positive, so you get 3.5. Now either you're going to do it that way, or you could have said, oh, okay, we're taking a look at maybe the y-coordinate first. So if I did the y-coordinate first instead, of 5 minus the x-coordinate of 1.5, you would have had the absolute value of 3.5, which is still 3.5. So it doesn't matter which order you take it in, you are still going to get the same length of 3.5 units. So go ahead, try out finding xz on your own. Pause the video, come back, and we'll see if we got the same answer. Now hopefully you ended up getting 4.5 for the distance of xz. The reason we ended up having the coordinate x, which was 1.5, and the coordinate z, which was a negative 3. So we took 1.5 minus, because it was the difference, negative 3. And when you do that, it's plus a positive, so it's really 1.5 plus 3, which gives us that 4.5. Even if you did it the opposite way around, you should still end up getting 4.5. Next example, I want you to find the total distance, or the distance between the points having the coordinates of 36 and 10. You're going to do the same exact thing as what we did before. Try it out on your own, pause the video, and we'll come back and have an answer for you. So I ended up getting a distance of 26 units because I took 36 minus 10 and the absolute value of that. If you ended up doing 10 minus 36, you would have gotten a negative 26, but you're taking the absolute value, so you still get a 26. Doesn't matter the order. That's how you find distance. So the second term we're going to cover in this set of notes is congruent segments. When we talk about congruent segments, they are segments that have the same length, or we say measure. So if we're taking a look at segment AB, you will notice segment AB here and segment CD. They look to have the same exact length. But how do we know? Well, we know because anytime we're dealing with congruent segments, segments are congruent if they're shown with the same number of tick marks. So AB has one tick mark, CD has one tick mark. That means they are the same exact measurement. So, notation-wise, very, very important. When you're talking about segments that are congruent, you will say segment AB. Notice the segment above. Segment AB is congruent to segment CD. So the segments themselves are considered to be congruent. But as soon as you start to talk about their lengths or their distances, you would then say that the length of AB, notice no segment bar above, is equal to the length of CD. So the segments are congruent, but their actual lengths, their numerical values are equal. Here's how I remember. Either they all have tops to them, so the AB segment has a top, the equal sign would have a top, meaning congruent, and then the CD would have a top, or they all do not have tops to them. So AB, the equal, and the CD do not have tops. So that's how you figure them out notation-wise. And in case I forgot to mention, this little symbol here with the squiggly above the equal sign, that means congruent. So now you've got that.
All right, so we're rolling into our next part, the segment addition postulate. Something to keep in mind is this postulate is the beginning to a whole bunch of other postulates that we're going to be seeing in this group of the addition postulate. This one is our segment addition postulate. It says, if we look at this example here, if B is in between A and C, then AB plus BC should give you the whole thing AC. So we write this out in something that's really easy to remember as part plus part equals the whole thing. All right, so I'll go through this first example with you. They want you to find the length of ST. And what you should notice is that in order to find ST, you have to know what X is. So we're going to use our segment addition postulate to help us solve for X first. Then we can plug it in and find ST. So we're going to start out with just simply looking for our parts and the whole thing, and then use our algebra skills to solve for X. So the first part you should see is the part ST. ST is actually 6x minus 4. The next part is TU, TU is 3x. And the whole thing here is SU, which is 5x plus 8. What I would like for you to do right now is pause me. I want you to solve for x, and then hopefully you can plug it back in and solve for ST. All right, going through the algebra, you should have ended up with x equaling 3. Okay, so if x is 3, then therefore, side note here, you might want to take notes on this. You guys are going to be using this often. These 3 dots, oddly enough, in the math world, crazy mathematicians, use these 3 dots to indicate the words therefore. We like to shorten things. We like to abbreviate things. These 3 dots will indicate the words therefore from here on out. So therefore, if I plug 3 in for ST here, 6 times 3 minus 4, well, you get 18 minus 4. The length of ST should equal 14. Oops. Sorry, you guys. One of these days I'll get used to this. 14. All right, up next is midpoint. When you hear the word midpoint, things that should pop into your head are middle and point. So this is a point that divides a segment into 2 congruent segments. So we're dividing a segment into 2 congruent segments. It is the middle point. Okay? So if I've got my segment here, PQ, and M is the midpoint, what happens is it creates 2 congruent segments. In this case, we have PM and QM that will be congruent to each other. Remember, if the segments are congruent, the measures are equal. When we're talking about just simple points on a number line, they're going to ask you to find the midpoint, the middle point between 2 points on a number line as well. So on a number line, the coordinate of a midpoint of a segment whose endpoints have the coordinates of A and B is just simply A plus B over 2. I like to think of this as just averaging out, figuring out where is the middle point. And to figure out average, you add things together and then divide by however many there are. And in this case, we have 2 points, a beginning point and an end point. If I add them together and divide by 2, I will find my middle point, the average point. Okay, so for the first example, it says find the coordinates of the midpoint of CE. So now we have to figure out what C is. Well, in this case, we notice that C is -2. And what E is, well, E falls here. Hopefully you'll notice on your number line that that is 7. So if I want to find the midpoint, I'm going to add the 2 together, divide by 2. So we have -2 plus 7, divide that by 2, and you should get 2.5. You'll notice 2.5 is located about here, smack dab in the middle of CE.
So for the next example, we have that Y is our midpoint of segment XZ. So as Ms. Feliniak said before, your midpoint sits smack dab in the middle between X and Z. And what we need to do is we need to find out what the value of the segment XZ is, what its length is. So if we know that Y sits in the middle, we automatically know with midpoints that we end up getting 2 congruent segments. Notice also with the double tick marks, that tells us that segment XY and segment YZ are indeed congruent. So if they're congruent, they have the same exact measurements, meaning we are going to set these 2 equal to each other. So we will have 2a plus 11 is going to equal 4a minus 5. Pause the video, try to figure out what a is, come back, and we'll get xz together. So hopefully you ended up getting a equal to 8. Now the problem was it said find the value of xz, meaning we're not done here. You're going to go ahead and take that 8 and shove it in. You're going to shove it in. Let's go ahead and shove it in for the a in yz. And when you throw it in there, 4 times 8 ends up giving us 32 minus 5 gives us a 27, meaning that yz is 27. If yz is 27, since xy and yz are congruent, we know that xy should also be 27. If xy is 27 and yz is 27, that means that xz is going to be equal to the addition of those 2 parts. Remember, segment addition, postulate, part plus part equals whole. Therefore, 27 plus 27 ends up giving us 54. Our answer for xz is 54.
All right, next example. Again, they're telling you that u is the midpoint of xy, and they want you to find xy. So very similar to what we just did. Now the issue here is last time you were able to set these two pieces equal to each other. But what happens is 4x plus 9 equaling 4x plus 9, everything's going to cancel out. You're going to have to work this a little bit differently. If you remember from maybe 2 or 3 examples back, if you see something like this where you have a part, and the whole thing, you should automatically just work it with the segment addition postulate. That way you can solve for x, then being able to plug it in and get your xy. So part plus part equals whole. You should have 4x plus 9 plus 4x plus 9 equaling 16x minus 6. Go ahead and solve for x, and then come back and we'll figure out what xy is. All right, hopefully when you work this through, you got x is 3. So now we're looking for xy. So instead of plugging it into each part like we did last time, we actually have something that's indicating what xy is. It's 16x minus 6. So I can take this 3 and go ahead and plug it in there. So if xy is 16x minus 6, that's 16 times 3 minus 6, giving you a total length of 42. All right, last example, everybody's favorite. We got a word problem. Woohoo! All right, first things first, you read through it, then you label your picture, and then we're going to solve. So we got our map here. Our map shows our route for a race. You are at X. There you are, getting ready to go. 6,000 feet from the first checkpoint, so that's 6,000 feet. The second checkpoint D is located in between C and Y. The total race is 3 miles, and then they want to know how far apart are the 2 checkpoints. So they want to know how far apart are C and D here. Okay? First things first, let's label. You're here, C's there, so this is the 6,000 feet right here. They also tell you that D is located in between C and Y. It's the midpoint, so that makes this congruent to this. So CD is congruent to DY. Then it tells you that the total race is 3 miles long. That should have sent up some red flags. We have 2 different labels here. We've got feet and miles, so we had to do some converting. My first question to you is how many feet are in 1 mile? And you should know that 1 mile is 5,280 feet. Okay, so to figure out how the total race is, the length of the total race, we're going to have to multiply that by 3. That makes our total distance from X to Y 15,840 feet. Now, because we're focusing on the length of the 2 checkpoints, the distance between the 2 checkpoints C and D here, we really don't need this 6,000 feet. So I'm going to take, first of all, the 15,840 feet and get rid of my 6,000 feet. Oops. Okay, that leaves me with a length of 9,840 feet. So that makes my distance from C to Y 9,840 feet. Now keep in mind, D is located in the middle, so these 2 are congruent. If I am looking for the length between the 2 checkpoints, C and D, all I will have to do is take half of the distance. So if I take 9,840 feet and I divide that by 2, I should end up with my length for CD, which is 4,920 feet. All right, you guys. So with that, I want you to make sure that you are doing your whisk. Remember, that means where did you watch your video, a summary of the video, and any questions that you had. Remember, we have a lot of examples in this one, so make sure you come up with some good questions. We will see you tomorrow, and have a good night.